Chapter number 3, Sequence and Series. We'll start with the sequence. Um, you know what is sequence basically, but let's discuss a bit of it. Sometime you may know some names of the sequences like linear sequence, quadratic sequence, um, Fibonacci sequence, harmonic sequence, uh, arithmetic sequence, um, geometric sequence, or progression also. Likewise, those are few examples for the sequences. And what is a sequence? What is a sequence? Sequence, we can tell that a sequence is an ordered list of objects. Or if we want to get rid of this ordered, because there's a meaning for it, we can also tell that a sequence is a list of objects with underlying rule. For example, if you consider this one, list of objects, for this has to be three dots. Three dots mean it's go up to infinity. If you see anything with the three dots, that's imply that it's go up to infinity. Now you can see list of objects. The first object, second objects, third object, fourth objects. So these objects are also called elements or terms. And what is the underlying rule? Underlying rule. The underlying rule is you can see that the number of side is increasing with 1 from term to term. So here 3 sides, 4, 5 and 6. Number of sides are increasing with unit 1. Usually we denote a sequence with A1, A2, A3, A4, or sometimes some books you can see T1, T2, T3, T4, or some books U1, U2, U3, U4, or sometime it is R1, R2, R3, R4. It's and it's up to the author basically, but those are the standard terms usually you use A, T and U. And I will add one more thing. A sequence is a list of objects with underlying rules, or this definition, and these objects not necessarily distinct. So what is the meaning of this? How about this one? This is also a sequence. And here A1, A2, A3, A4. This is A1, A2, A3, A4, A5, A6. Now here A1 and A2 two different A1 not equal to A2 in other way. This is triangle and this is a square. But here A1 in this sequence, A1 equal to A2. Okay, I will write T. So here T1 equal T2. So this is something we should know. Among the sequence, we can see some different type of sequence according to the characteristics. One sequence, increasing sequence. 1, 3, 5, 7, 9. So those are the objects. You know underline rule. The difference is 2. And so this is a sequence and this is increasing sequence. You can see that the number is increasing. Or 9, 7, 5, 3, 1 and -1. Likewise, this is a decreasing sequence. 9, 7, 5, 3, 1 dot dot. And other one, finite sequence. Not infinite. Limited number of terms. For example, if I remove 3 dots from here, 1, 3, 5, 7, 9, and no 3 dot, it means not continuing. So limited number. Finite sequence. And infinite. 1, 3, 5, 7, 9, and this is I put 3 dots. It means the same one. If I put 3 dots, it means it's continue up to infinity. So infinite sequence. So then how do we write uh, increasing finite sequence? Increasing finite sequence. So make it finite but also increasing. 1, 3, 5, 7, and 9. Increasing as well as finite. So increasing infinite. So the same sequence increasing 1, 3, 5, 7, 9. Put 3 dots. It means it's continue up to infinity. The same way, decrease in finite. Take decreasing numbers 9, 5, 9, 7, 5, 3, and 1. That's all. It's decreasing. And finite because 1, 2, 3, 4, 5 terms there. And the other one is decreasing infinite. So that is the same thing 9, 7, 5, 3, 1 and dot dot dot. 3.1 arithmetic sequence. Arithmetic sequence difference between two consecutive terms is constant. That is, let's say A1, A2, A3, A4, AM, AM minus 1, AM, AM plus 1, AN, AN plus 1, dot dot, um, comma. Basically, difference between two consecutive terms is constant. A3 minus A2 is constant, or A2 minus A1 constant. AM minus AM minus 1 constant. This is M term. Then 1 before M, M minus 1, 1 after M, M plus 1 constant. And AM plus 1 minus AM is constant. AN plus 1 minus AN is constant. Difference, this is also a difference actually. A2 minus A3. This is also a difference. So basically in this arithmetic series, we always reduce in this form, AM plus 1 minus AM. That is any term minus previous term. So we should not consider this one, always will stay with this. We'll discuss an example. 1, 3, 5, 7, 9, dot, dot, dot. So this is a sequence. And this is first term, U1, 3 is second term, 5 is third term, and the common difference when we check the difference between two consecutive terms, 5 minus 3, 2, 3 minus 1, 2, 7 minus 5, 2, 9 minus 7, 2. So then the common difference is fixed and difference is common, and so this is arithmetic series. So then the first one is first term. The second term is 1 plus in terms of the common difference. So common diff is 2. So 2 times 1, which is 3. And then the third term with 5. So 1 first term and common difference how many times? 2 times. And the 7, that is 1, 2, 3, 4th term in terms of first term plus common difference 2 and how many? 3. So this common difference is same. Now you can see when term is first and second, this is 1, 2, 1, 3, 2, 4, 3, 5, 4, 199. So likewise, so if you want you 100 term, you are writing first term plus the common difference and one number less than this amount, which is 99. And you need n term, then you want 1 the first term plus 90 common difference plus 1 before n, that is n minus 1. And instead of 1 you can write what is 1 mean? u1. If you won't write u1. Let's discuss another example. 2468 dot dot dot. It's a sequence. You don't know what is it yet. So you found the common difference. 4 minus 2, 2. 6 minus 4, 2. 8 minus 6, 2. So you have the difference. Difference is common. So we call common difference is 2. Now you want to write 770 terms. So let's say u 770 term. Then what do you want? You want first term. Do you know first term? Yes, 2. And you want the common difference. Yes, that is 2. And multiply with the 1 before the term number. 770, 769. 770 minus 1. I want to write the m term of this one. M term. So m. Then you need to know first term. Do you know first term? Yes, 2. And then the common difference, do you know? Yes, 2. And what is this number? 1 before the term number. Term number is m. Then it should be m minus 1. I need a square term. Then you need a square. Then first term and second and a square minus 1. In general, how do you write the term? Any term in general. So we write u n term. First term, usually we write a, and the common difference we write with d, and this number is 1 before the term number n minus 3. Let's discuss example 1 in the book. So that is un equal 55 to n, 2 times n. Before that, let me discuss 1, 3, 5, 7, 9 dot dot. So we wrote the nth term un equal first term plus the common difference 5 minus 3 2, and this is n, so n minus 1 times 2. So 1 plus, I'll bring this 2 here, 2 times n minus 1. So 1 plus, I'll expand this one, 2n minus 2. Basically 2n plus 1 minus 2 minus 1. So un equal to n minus 1. Now if you have this one given, un equal to n minus 1, how do you write the first term? First term. So n equal 1. So u1 equal 2 times 2 minus 1, which is 1. N equal 2. So u2 second term. 2 times u2. 2 times 2 minus 1, which is 4 minus 1, which is 3. This one. And the third term. First, second, third term. N equal 3. u3 equal 2 times 3 minus 1, which is 6 minus 1, 5. 5. So likewise, if we have this one, then inversely you can find the terms as well. Now you have this equation is given. It possibly come from a arithmetic series or something else. Who knows? So first of all, to identify this one, we need to know the terms. So what is the first term? Okay, part A, the question they are asking, write down 5 terms. First 5 terms. So n equal 1. The first 5 terms are u1, u2, u3, u4, and u5. So then n value has to be 1, 2, 3, 4, and 5. So we'll start with this one. u1 equal 50 minus 2 times 1. 50 minus 2, that is 53. So then this is n equal 1, n equal 2. So which is u2. That is 55 minus 2 times 2. So 55 minus 4, which is 51. And f equal, now don't assume this is arithmetic series and you can see 53, 51. Then difference is 2. So then you can write the other one is 49, 47. Unless they said this is arithmetic series, don't do it. So you have to find. So n equal 3, u3 equal 55 minus 2 times 3, 55 minus 6, that is 49. And n equal 4, u4, 55 minus 2 times 4, 55 minus 8, 47. And n equal 5, u5, 55 minus 2 times 5, 50 minus 10, that is 45. Now when you look at this one, 53, 51, 49, 47, and 45, and you can see this is a decreasing series, and it's go on like this. If I put 3 dots, it's becoming finite series. And question number 2, find the 99 terms of this sequence. So basically, now they want to find what is 99 term. So n equal 99. So we know that nth term, that is 55 minus 2n, then u99 is 55 minus 2 times 99. So 55 minus 198 and minus 143. So this is the part B, the 99th term. Part C, now we need to find the term with that sequence get that is sequence is the first term in the sequence that is negative. So basically 53, 51, 49, 47, 45. So likewise, first term is not negative, second term also not negative, third term also not negative, fourth not negative, fifth negative. And we found out 99 term is negative, 100 and minus 43. It means, so it is moving positive to negative. So there is a place that the last positive term after this term, it is all positive and all negatives. Basically you will find a boundary. In this boundary, let's say am and am plus 1. So am is positive and am plus is negative. For easy understanding, I will make this is m and this is m minus 1. Now this is the first term, okay, u1, since this is u, so u1 greater than 0, u2 greater than 0, u3 greater than 0, this is greater than 0, and am minus 1 also greater than 0, but am is less than 0. So we need to find this m value. We know that this um should be less than 0. What is mean? Instead of m, change the m. So 50 minus 2m less than 0. Then 55 less than 2m. And the same thing I can write 2m greater than 55. So m greater than 55 divided by 2. This is the same thing I wrote. And this is m greater than 27.5. So then this is a decimal number. So the next integer is 28. Then m equal 28 is the negative number. Basically m28 less than 0, m27 is greater than 0. What is m28? Let's find m28. m28 equal 50 minus 2 times 28. 55. This is 20, 40, 56. So that is minus 1. So this term is minus 1. And what is this term then? That is U27. Or you can add 2 to this one. The common difference is 2, so this is positive 1. So we'll see that 55 minus 2 times 27, 55 minus 54, which is 1. Let's discuss example 2. Example 2, we need to find so it is given that the arithmetic sequence. This is a arithmetic sequence. So you know arithmetic sequence means and the difference between two consecutive is constant always. So 20 minus 6, that is 14. 34 minus 20, 14. So the common difference is 14. That's all you need to know. And the first one, 6. Then you can write m term is, okay, nth term is first term plus the common difference and one number before this term number, that is in minus 1. You want m term, first term is 6 and common difference is 14 and one number before this term in minus 1. So un equals 6 plus 14 times n minus 1. I'll bring this one here. 6 plus 14 n minus 14. So 14 n minus 8. Part B, A equal 101, D equal, it's better to write like this. You select any two. I think this is 73. So I'll take this one, 94 minus 101. So is minus 7. Now the nth term is first term and 1 before this number with the common difference. It is a negative, so I put in the 101 minus n minus 1, 7. Minus times plus minus. So 101 minus 7 n minus 1. So 101 minus 7 n plus, so 108 minus 7 n. Example 3, after you read this question, un equal a n plus b given. There's a sequence. Even we don't know this is arithmetic or any other sequence, it doesn't matter. And u3 is given 5 and u8 is given 20. I think it is 8, yeah. u8 is given 20 and u3, so n equal 3. So we'll submit, we find u3 indifferently. When we put n equal 3, then u3 equal a3 plus b or 3a plus b. Then u8 equal 20. Again u8, when you put n equal 8, so u8 equal a8 plus b, that is 8 a plus b. Now we need to find a and b. Now we have an equation 3a plus b equal 5, 8a plus b equal 20. Now we can see that two equations and two unknowns. So we have to solve simultaneously. And 2 minus 1, because I can see that this 20 number is bigger than 5. That's why I went for 2 minus 1. So this will give, okay, I will do proper 8a minus 3a plus b minus 20 minus 5. So 8a plus b minus 3a minus b equal 15. Plus ba minus a cancel out. 5a equal 15, a equal 3. Now from 1, b equal 5 minus 3a. So b equal 5 minus 3, a is 3. So 5 times 9, which is minus 4. So in here you can write n equal 3 and n equal 8. So they need to complete when